All right, let's dive in. Today, we're building a hotel booking app from the ground up. We're going to peel back the curtain on the kind of architecture it takes to handle millions of people, all trying to book that perfect room, all at the same time. Let's do it.
You know that feeling, right? You're scrolling, trying to find a hotel, and you just kind of wonder, how does this actually work? I mean, what's really happening under the hood when an app like Booking.com has to juggle millions of users, check if a room is still available, and then handle your credit card, all in a split second?
Well, it's this incredibly complex dance of data, timing, and security. But here's the good news. We're going to break it all down. We'll go step by step, piece by piece, so you can see exactly how it all comes together.
Okay, here's our game plan. We'll start by figuring out what we're building, then design the foundation, the API. From there, we'll look at the app's blueprint, tackle some really tricky problems, and wrap it all up with the key takeaways.
All right, section 1. First things first, you got to know what you're building. Let's dig into the core challenge and figure out the scope.
Look, in any project like this, the first thing you have to do is focus. You just can't build the entire universe at once. So let's say the interviewer tells us, keep it focused. We're at about 5 million monthly users and just assume they're already logged in. Boom! That gives us our target. We're not worried about logins or user profiles right now, just the core booking flow. That's what makes this whole thing possible.
So what does this app have to do? Well, functionally, the basics, right? You got to be able to search for a hotel, get some smart autocomplete suggestions, check out the details, and of course, book the room. And yep, that includes that little pressure-inducing countdown timer we've all seen. We also need offline access for confirmed bookings. But then there's the non-functional stuff. It has to be fast, always available, and this is the big one. Data has to be rock-solid consistent. Double booking a room? Not an option. Ever.
Okay, requirements are set. Now let's lay the foundation. Section 2 is all about crafting the API contract. Think of it like this. The API is the set of rules for how the app and the backend are going to talk to each other. It's got to be perfect. And this endpoint right here, post/v1/reservations, this is a big deal. When you hit that reserve button, this is what your phone calls. It's what kicks off the whole process. But it also opens up a huge potential problem. What happens if your internet is a little shaky and you accidentally tap that button twice? Do you get charged twice?
No, you don't. And here's why. Something called an idempotency key. It's a fancy term for a simple idea. The app creates a unique ID, like a request ID for that one booking attempt. It sends it to the server. If you accidentally send it again, the server sees the same ID and goes, nope, I've already seen this one, and just ignores the duplicate. This one little key is absolutely crucial. It's what stops you from accidentally booking and paying for the same room twice.
All right, so we know how the app and server will talk. Section 3. Let's zoom out and look at the app's actual blueprint, the high-level architecture.
So we're not just throwing everything into one big pile. We've got layers. The UI layer, that's everything you see and interact with. The buttons, the lists. The data layer is the brains of the operation, managing all the hotel and reservation info. And then there's the network dispatcher. I like to think of this as the central command center for all communication. It talks to our backend, grabs images quickly from a CDN, and connects to payment services. It organizes all that chaos.
Okay, foundation's in place. Now for my favorite part, Section 4, solving the really tricky problems. This is where the magic happens. We're going to do a deep dive into 3 of the hardest challenges here.
First step, that reservation hold process. You know the one, the little countdown timer that starts ticking, creating all that urgency. So how does it work? Well, the second you start the process, the backend basically says, okay, this room is yours for the next 15 minutes. It puts a temporary hold on it. Then it tells the app exactly when that hold expires. Your phone shows you the ticking clock, and if you don't finish in time, poof, the hold is released and the room goes back into the pool for someone else. It's a really smart system.
But wait, how do you make sure that timer is legit? I mean, you can't just trust the clock on your phone. A sneaky user could just go into their settings, roll the time back, and give themselves an extra hour. No way. The only reliable method is to make the backend server the single source of truth. The server gives the app an authoritative timestamp, an exact moment in time when the hold expires. Then the app uses the phone's internal uninterruptible uptime clock, when you can't mess with, to calculate the time remaining. That's how you make it cheat-proof.
Next up, autocomplete search. How do you make it feel lightning fast? You've got a few options. Strategy 1, stuff all the data on the phone. It's offline, it's instant,
but the app would be massive and the data would get stale fast. Not great. Strategy 2, ask the server for suggestions every time you type a letter. The data would be fresh, but it would feel so laggy. So what's the answer? You guessed it, a hybrid approach. We give the app a lean, local dataset of the most popular searches so it feels instant. And then we smartly fetch more specific results from the API as you type. It's more complex to build, but it gives you the best user experience by far.
And finally, the most sensitive part, getting paid. The secure payment flow is non-negotiable, and the #1 rule is our app, our servers, they never ever touch the raw credit card number. Instead, the process looks like this. The app uses a special tool, an SDK from a payment provider, like Stripe. That tool securely collects the payment details. It then gives our app a special, one-time used payment token. We send that token to our backend. Our backend verifies it with the payment provider, and only then is the booking confirmed. It keeps everything incredibly secure.
Okay, we've covered a lot of ground. So let's wrap this up in Section 5 and summarize the most important decisions we made along the way, our key design takeaways.
So here it is, the final blueprint. It really comes down to these key decisions. 1. For reservation holds, the backend timestamp is the single source of truth, no exceptions. 2. For autocomplete search, we use a hybrid approach to get that perfect balance of speed and freshness. 3. For storing that data locally, we're using a solid SQLite database with full-text search capabilities to make it fast. And 4. For payments, we integrate directly with a third-party PSP on the client side. That's how we get maximum security. These are the pillars that make the whole thing work.
And that's our design. It's a system built to be secure, fast, and super reliable for 5 million users. But it leaves us with a really interesting question to chew on. What would need to change to handle 50 million users? What parts of this design would start to creak and groan under 10 times the load? Something to think about. Thanks for joining me.